Hey everyone, we're going to find the inverse of the rational function given here. We're going to check that we did it right and state the domain and range. Since I usually do it right, I'm going to go ahead and do the domain and range before I verify. It saves space on here. So basically, I'm going to change my f to y. And then I switch my x's and my y's because that's the inverse. So there's your inverse. But now we want to solve for y so we can verify, and also later videos we're going to graph these. So when you cross multiply, put that in fraction form if you want. Now I'm going to group my y's together. I'm going to put my y's on the left and my x's on the right. So basically I'm going to move the 2y over and you get xy plus 2y, and I'm going to add the x to both sides. So I'm adding x here, and I'm adding 2y to both sides. So, and I'm adding x. So this would cancel, and you're just going to get x over here. Now what we're going to do is, I'll do it up here, factor out the y, so you get x plus 2 equals x, and then you're going to divide both sides by x plus 2. And there's your inverse. All right. Make sure I did it right. Yes. Okay. Now I want to state the domain and range of both of these. My domain, do it right in here. My domain of f equals my range of f inverse. So my domain of f of this is all real numbers. And it can be everything but 1. So you divide, if you put a 1 in here, you'll get 0 in the denominator. So my range is the same thing, but you just put the y. Because remember, we switched the x and the y's. And then my range of f equals my domain of f inverse. So here's your f inverse. So that's all real numbers, but x cannot be negative 2. Therefore, my range is y, such that y cannot be negative 2. All right, and now we have to verify. And the way we verify is compose f with f inverse. And when we do that, we should get x. So basically, I'm going to input my f inverse, which is x over x plus 2. And I'm going to write down my outer function, negative 2, and there's an x. Then I have x minus 1. And my x happens to be my inverse, which is x over x plus 2. And to make this easier, what we're going to do is clear the fractions by multiplying the numerator and the denominator by x plus 2. Now, go ahead and FOIL that, or distribute, and you get negative 2x on the top here, and this will cancel. And here we're going to distribute. So this is going to cancel. So you're just going to get x minus, and when you distribute here, 1 times x plus 2. So that's be negative 2x over x minus x plus or minus 2. So I almost didn't distribute my negative there. Okay, so I have negative 2x over negative 2. That cancels, and you're left with x, which is what we wanted. Now we have to go the other way. We have to compose f inverse with f of x. Okay, so write f inverse. My inner function is f, which is negative 2x over x minus 1. So my outer function is negative 2x, which is just x, over x plus 2. And I'm going to input my f, which is negative 2x over x minus 1, negative 2x over x minus 1. I'm going to clear the fractions and put that in fraction form. So you can multiply by x minus 1. And what happens is these will cancel. So you just get negative 2x. And this is going to cancel. So you're going to get negative 2x again, plus 2, and you have to distribute here. 2 times x minus 1. So I get negative 2x over negative 2x plus 2x minus 2. And that's with me just distributing here. And that's going to give you negative 2x. These cancel. That's 0 over negative 2, which equals x. Okay, the next problem is very similar. And then we'll move on to some harder ones. Thank you. Have a nice day. Bye-bye.